don't do this without proper professional help. That's my disclaimer. Hello and welcome back to the shop. Today we're going to be working on our studded wall project, and this is entirely too long of a section of wall for me not to have electrical outlets. I mentioned in a previous video, the only electrical we have back here is electrical that I've added. We have one receptacle on our 2-post automotive lift, and then we have a 2-gang receptacle, so 4 outlets right here on the switch plate to the lights when you walk into the room, and that's it in this whole back section. So this section is about 55 feet long, 26 feet wide, and we have 6 outlets. So obviously that's not good enough. I need to add a lot more. It's a perfect opportunity while we have it in open studded form for me to add a ton of electrical outlets, and we're gonna add 10 2-gang boxes. So thanks for joining, come along and I'll show you how it's all done. All right, so currently the only power electrical outlet wise that I have in here is 2 outlets over here. So it's 1 receptacle on the 2-post automotive lift, and then we have 2 outlets right there, and they're always full, taken up with either charging camera equipment batteries or shop fan or something like that. So we're gonna take our time. While we have all this in studded form, we're gonna add a bunch of outlets. I plan on doing one every 4 foot, but it just didn't work out measurement wise and number wise. It was too many outlets on one circuit. I want to limit the amount of circuits that I'm going to have in here and limit the amount of outlets I'm going to have on each circuit. We're going to dive into the details a little bit later on in this build, but we're going with 10 2-gang boxes all along this wall. So we have 56 linear feet of wall that we want to fill, and we're doing every 64 inches because our studs are 16 on center. Every 48 inches was a little bit too close, and it won't allow me the ability in the future to add like wider cabinets and things like that. So we went with every 64 inches, and I think that works out perfectly. That's going to be 10 2-gang boxes. That's going to be 40 actual outlets, 20 receptacles. So let's go ahead and get busy doing that, and I'll break everything down later on in the video. First thing we have to do is hang the outlet boxes. All right, just to give you a kind of a rundown of what we've got 8 outlets total on this wall and 2 outlets on the other wall back behind me over that way. Our slab is about 5 inches thick, so I measured from the top of the slab to the top of the box 48 inches. That way, when I go slide whatever kind of choice of drywall, sheathing, or whatever else that we're gonna be putting up there, that all I have to do is cut from the top of the sheathing down around the electrical outlet box, and then I can stick the other sheet on top of that without too much cutting. The only one we are going to have to cut around is this one right here, and I wanted it partially because I like the idea of at least 1 outlet underneath whatever, bench top or cabinets or whatever that I end up putting over here in the future. And 2, I needed something down low for my refrigerated air dryer that goes right here for our air system. All right, so just to give you an overview of what we got going on, we're gonna have 4 separate circuits for our 10 2-gang outlets. So in each 2-gang box, there's gonna be 2 receptacles, which gives me 4 outlets per box. Left side of the 2-gang box, I'm gonna have 1 outlet. On the right side, I'm gonna have another outlet. The left side, we'll call that circuit 1. The right side, we'll call that circuit 2. We're going to run 2 separate wires to those. And that just helps with balancing the load. You don't want to have 4 outlets all on one circuit. At least I don't, because I do plug in a lot of high amperage stuff that requires a little bit of starting load capacity and things like that. So it's a lot more beneficial for me to have 1 outlet on one circuit and the one right next to it on another 120 volt outlet circuit. That way, there's just I can have the shop fan going along with a chop saw and some other things plugged in and have no worry about popping a breaker. That's why we're limiting each run to 5 receptacles, which is 10 total outlets. Each receptacle is 2 outlets. So for the first 5 boxes, it's going to be circuit 1 and 2. And for the next 5 boxes, is going to be circuit 3 and 4. And we're not really going to take up any more room in our box because we're going to be using these tandem circuit breakers. And what this allows you to do is to fit 2 separate circuits in a single spot. I have some plans for the rest of the panel later on, so I don't want to take up more spots than I need to. We're further going to help balance that panel. You don't want all your outlets, even if they're on separate circuits, on the same leg, as what they call it, on the same leg of the panel, because what that means is everything that's connected to those, even if they're separate breakers, they're all on the same side of the panel. So you don't want that to occur, because they're basically pulling off the same leg of power. So I don't want all my lights and then all these outlets on the same leg. And the reason you don't want to do that is if you have some high amperage tools that you're starting and stopping repeatedly, you'll notice your lights usually flicker or dim. Now, I'm not suggesting you go in your panel and start figuring out how to rearrange it or anything like that. And as always, consult a professional before you do any electrical work whatsoever. So I've rewired my whole house. I've been in trades before, so I am very familiar with electrical work, and I know the risks involved. So another thing to note is I'm going to keep my electrical outlets, even though they're 4 separate circuits. I'm not going to tie in any lighting whatsoever. The last thing you want to be doing is having your lights go out as your chop saw or table saw is running down because you popped a breaker. So I'm going to kind of make this a little bit safer and a little bit more reliable in that sense. I haven't had any issues with popping breakers or overamping anything, but I just kind of want to future-proof it for any kind of things that I start getting involved with in the future. So do it the right way, do it once, and move on to something else, right? What I'm going to end up doing is balancing the load by putting my outlets on one side of the panel and putting the lights on the other side of the panel. I'm actually going to reverse those from the back half of the shop to the front half of the shop. That way the outlets on the back half of the shop are on one leg, while the lights for the back half of the shop are on another leg, and again vice versa for the front of the shop once we get around to that at a later date, because all we're concerned about right now is this project and what we're doing here. So we're going to do this with 2 20-amp tandem pole breakers. That gives us 4 circuits of availability and only takes up 2 spots in the panel. So we're going to get to pulling wire, drilling holes, and get all this stuff laid out. All right, so we've got our 2 circuits here. I've already cut this loop, but this is a single run all the way down the wall, just like this one is. I just cut it right here. So again, the purpose of this is to have 1 circuit on this outlet and 1 circuit on this outlet. That way there's 2 separate 20-amp circuits powering 2 different outlets for 2 different receptacles and 4 different outlets, so you can plug something in the left side and plug something in the right side and not have them on the same circuit or overload anything. This is a standard duplex receptacle. It has 2 outlets on it, and on the left side you're going to have silver connectors, and on the right side you're going to have gold connectors. And just look at the screw color is what we're trying to determine here. So we have gold screws on the right, the little outlet, silver screws on the left, the big outlet, and then obviously this funky little half dome here in the bottom, that's going to be your ground connector, and that connects to the green connector down there at the bottom. Now on the electrical outlet, you got to figure out what color wire goes to what, and it's black to gold, or black to the little side, and white to silver, or white to the big side. You might be tempted to, since this is one continuous run with just a break here in the middle where we're going to put the receptacle, you might be tempted to either using the quick connects, which those are just push-ins. We can't use those because we're using 12 gauge wire, and these are for 14 gauge wire. So we are going to be using the screws here on the side, but you might be tempted to come in here and hook up this receptacle just like this, with both blacks on one side, come to the other side, and connect the white wires. I would advise against that, and here's why. Because if this outlet fails in the future, just like Christmas tree lights, all the other outlets in line from that are going to go out. So, and then you won't know where the problem exists until you get back to this bad outlet, and then you'll have to replace this outlet. So what we're going to do instead is we're going to connect the white wires together, the black wires together, the grounds together, and then we're going to add pigtails connecting these to this. That way there's always power feeding through this, and just happens to branch off and feed the outlet in line with everything. That way if this outlet fails, that's the only thing that goes bad, and whatever you got hooked up to it is just non-powered, but all the other remaining outlets in line of the same circuit continue to work as normal. One down, 19 to go. All right, guys, we got all the outlets in except for the outlets that start the run. Typically, those will be GFI outlets, and they would protect the circuit all the way down for ground fault circuit interruption, or in case you got water on it. So we're going to be putting in GFIs at a later date just to get this project finished up. We're just going to put in normal outlets. It's not recommended, so check your local code if you're doing this yourself, and don't do what I do, because I'm just some random guy on YouTube who's not an electrician by trade. So consult with a professional and get the advice you need to do the project properly. We appreciate it as always. Thank you so very much for watching this video, and if you haven't done so, please click that subscribe button to see future content. Ring that bell notification, that way you get notified just as soon as I get around to posting the next video. We will see you next time.